Welcome to Unit 1, Lesson 1, Properties. I'm going to go over a lot of properties here, and you may remember some of them, you may have heard of them, you may not, but what I think is really important is for you to understand what's going on, not necessarily for you to memorize the name of the properties. There is a reason that we go over these in math, and it's so you understand that these kind of things can happen. So let's start first with commutative property. Commutative, associative, distributive that you see on this page, these are common ones that you'll hear a lot. There is key words in here that kind of help you. Commutative kind of has the word commute in it, which means to move around. Associative has the word associate in it. When your parents would say, I don't like who you associate with, right? What they're talking about is who you hang out with. And then distributive has the word distribute in it, which means to kind of hand out. Those are kind of a good way to remember these particular properties if you're trying to memorize them. The commutative property, though, has that word commute in it. Basically what that means is that you can move your numbers around and you could still get the same result for an addition or a multiplication problem. So it allows, I understand that this may not be the best handwriting. It's kind of a little difficult to write with this, so I apologize. I tried going with a thinner pen, but it really looked terrible. Allows you to move two numbers around. Now this is for addition or multiplication, and get the same answer. I'm going to use some very simple problems to show this, to demonstrate this. Get the same answer. Okay, so for example, if I was doing addition, 3 plus 4, that's equal to 7. And 4 plus 3, that is also equal to 7. That's the commutative property. They commuted or moved around. If it was multiplication, the same type of thing. I could have 5 times 8. Did you know that parentheses, by the way, when you have a number right next to a parenthesis, that means multiplication? It does. That's the same thing as 8 times 5. Other ways that we could show multiplication, you know this one. I'm not a big fan of that because the x later on is going to be a variable, and then some people get that confused. There is also the option of putting a dot in between them. That is another way that you could do it. More than likely, I'll be using parentheses most of the time. Just understand that those are different ways to write it. The other one is associative, again with the word associate in there. This has to do with grouping. So change grouping. I'm going to kind of go write really short so the video isn't super long, because I'm not looking to waste your time. Changing the grouping without impacting, God, my handwriting's bad, impacting the answer. Again, sorry about that, but you can hear my words and then you can kind of get it, right? I think so. All right, so for example, if I have in parentheses 1 plus 2 plus 3 out there on the outside, order of operations, if you remember them, would tell you to add what's in the parentheses first. If you don't worry, we're going to do order of operations soon. But that would be the same thing then if you took the 1 on the outside and you said put the 2 and the 3 on the inside. It changed that grouping, the parentheses, from one set of numbers to the other set of numbers. This also applies if it was multiplication, 4 times 5 times 6. Notice I put the 4 right next to the parentheses because that means the same thing. Or I could go like this, 4 times 5, and have the 6 out there. It doesn't change it. Now, one thing that's important to note for both of these properties, they have commutative property of addition and multiplication, and then associative addition and multiplication. That doesn't mean that you could have addition and multiplication in the same problem and just do whatever you want to with the numbers. That's not what we're saying. What we're saying is that the commutative property applies for an addition problem, and it applies for a multiplication problem. And the same thing with associative. So don't think if you have a bunch of stuff that you can just throw it around whichever way you want, because that's not the case. We do have order of operations for that. Distributive property. Distribute just means you're allowed to distribute a number. Love this property. We're going to use it a lot. Distribute means to kind of hand out, right? So you're going to hand out the numbers. So it allows you to distribute. Hey, I almost think my handwriting, no, it's not. I was going to say getting better, but it's not. Who are we kidding here? A number, and this could be or a variable. Later on, you'll see that. um, I'm trying to think how to word this, is being multiplied. Multiplied. Wow. Sorry again for the handwriting. This is really bad. By, it's just because I'm writing a bunch of words. For some reason, the numbers turn out really nice, though. A group. Two, or a set. Yeah, a group or set. Set of added or subtracted numbers. That is probably horrible sounding. Subtracted numbers. But hopefully it'll make sense when I show you an example. So that's what I want to do next. Let me move this thing kind of out of the way. Isn't that cool? I love this tool. All right. So now what I'm going to do is I'm going to give you a sample problem. And wow, let me just move this whole thing. I'm going to move this whole thing because I'm kind of out of space here. Whoop, there we go. Now I got some room to work. So if I have 3, for example, it takes a number that is being multiplied. So right here I said a number that is being multiplied by a group. So the group is going to be in parentheses. I have 4 plus 5. Okay? And it allows you to distribute it or hand it out to those other numbers. So normally you would just do the 5 plus 4, which is 9, and then add it to the, or multiply it by the 3, which is 27. What we're saying here is that you can actually take this and multiply it by each of the numbers on the inside. So 3 times 4 is 12, 3 times 5, put the addition here, is 15. You can add those together and you still get your 27. That is a beautiful thing, and we're going to use that a lot. So let me show you one for subtraction. If I have 5 times 4 minus 3, what we could do here is we could do 5 times 4, 5 times 3. So 5 times 4 is 20. 5, and we put the subtraction in. 5 times 3 is 15, and you get the answer of 5. If you did it order of operations, 4 minus 3 is 1, times 5 is 5. You see that it works. Now, on to some other properties that I kind of think, why do we have these? Or at least, why do we have these defined? Because they seem a little silly. First of all, the identity property. Anytime you're talking about identity, right? Here's identity and here's identity. It means who you are, just like your identity. It doesn't change. So that's an important thing to keep in mind. The identity property of addition. What could you add to a number and it would never change that number? 0 is hopefully what you're thinking. You could add 0 to anything and it doesn't change it. That's the identity property of addition. Any guess on what the identity property of multiplication is? What can you multiply any number by and not change it? 1. So, identity property of addition, if you add 0 to a number, it doesn't change the value. Duh. Why do we have to write that? I don't know. I hope you don't need a sample problem for this one, but you know, you may. Here, if I took 5 and said, hey, put 0 to it, what do you have? 5. What? Its identity is the same. I know. Then, identity property of multiplication, you can multiply by 1. If you multiply by 1, it doesn't change the value. Again, shocker, right? Change the value. Again with my handwriting, sorry. But now this is very useful for another thing, because here I could say something like 3 times 1 is equal to 3. Yeah, great. This is where it's going to be helpful later on though. If I took 3 and I multiplied it by 4 over 4. Now if this hurts your brain, I'm sorry, we will go over this later. But 4 over 4, 4 of 4 things mean you have one whole. Anytime you have a fraction and the top and the bottom are the same, that's equal to 1. So this essentially then, right here, is the same thing as 1. You multiply that and you still have 3. That is something that's useful later on, and you'll see that. So I like that part of it. All right, and then we got the multiplicative property of 0. Wow, that's a really fancy way of saying if you multiply something by 0, you get 0. Okay? That you should know. So, if, oh, I still have my highlighter on. If you multiply by 0, you get 0. Shocker. Again, we dedicated an entire property to something that we already know, but we have it. So I have some really big number, 5,895 times 0. What is it? It's 0. Okay, you just have to understand that. Additive inverse property. This is a great one. We're going to use this a lot with solving equations, especially addition and subtraction type equations. This says if you add any number to its opposite, you'll always get 0. Add any number to its opposite, and you'll get 0. So, opposite of a positive number is a negative. The exact same thing. Opposite of a negative is a positive. But it's not just any positive or any negative. So if I have 3, for example, it's a positive 3. And I added to it its opposite, which would be a negative 3, the answer would be 0. Now, if you need proof of this, this may help you, it may not. If it confuses you, I'm sorry. But if you had a number line here, right? Here's my number line. And here I have 0, 1, 2, 3. And I was starting right here at 3. And then this said, hey, I want you to go a negative 3 or a negative 3 direction. You end up right here, which is 0. And again, if that was painful, I'm sorry. I'll even erase it if it makes you feel better. There, see, all gone. All right, moving on, we have the multiplicative inverse property, our last property of the day. When you multiply a number by its reciprocal, you get 1. So, multiply, wow, I'm having a little trouble here. I need some coffee or something. I erased part of it. Oops, what did I do? Sorry, I'm back. Okay, yeah. Multiplying a number by its reciprocal. That's really bad. Okay, I'm going to redo that because some of you guys might not know how to spell reciprocal. And what I did was I just killed that word. By its, here, watch me write good handwriting here. Reciprocal. Maybe I just drank too much coffee and that's why it was like that. There's no such thing. Okay, so by its reciprocal equals 1. So, first of all, what is a reciprocal? It is the number, so if it's a whole number, it would just be the number over 1. If it's a fraction, it's the fraction flipped. So, for example, if I have 3/4 and I multiplied it by its reciprocal, you multiply fractions, you go straight across, so you would end up with 12 over 12, which is 1. If I had a number 4, a whole number, and a 4 is equal to any whole number can be made into a fraction by putting it over 1, by the way. So this is the same thing as 4 over 1. Multiply it by its reciprocal, which is 1 over 4. Again, straight across, you get 4 over 4, and that's equal to 1. So multiplying any number by its reciprocal is equal to 1. All right, that is the end of the first lesson. I'll have these notes for you available in the link below. I also have practice problems for you. And good luck, and hope to see you in lesson 2.